Okay, so I said yesterday that whenever we have a bit of code that has a well-defined input and a well-defined output, we should wrap it in a function, and that's something I wasn't doing for this bit of code. This was just some lines of code in an amorphous block of code. But what we want is a well-defined function, and now that we know that our inputs are going to be meal values and tip values, and our output is going to be some final value, let's encapsulate it into a function so we can combine it with other function and make use of it again and again. So here's how you might convert your script to contain a function. We're going to leave the import sys at the top. We're going to have our code comment still, but the next line is going to be def, which is the keyword to define a function, and then I'm going to define a function called calculate tip. And what that will do is take two inputs. One is a meal value and one is a tip value. So calculate tip takes two arguments, two inputs. I then have colon, new line, and indentation, and all the processing that I want to do within my function is going to be defined, indented underneath the definition. So the first two things I need to do are convert those meal values and tip values to floats. The same thing we did before. But notice now we're not using sys.argv, we're using the inputs to our function. So the meal value is converted to a float and stored as the meal variable. The tip value is converted to a float and again stored in the tip variable. The tax variable we're leaving the same. We still calculate the total in the same way. And finally, rather than having the print statement, we want to return that total. So remember, a function has inputs defined after the function definition. Here is our inputs. There are two inputs, meal and tip. And it has outputs given after the word return. So our inputs are meal and tip, and our output is this total variable. So that's great. If you look at all the code up to the return value, what it will do is define that function. It won't actually run that function. It won't know what values to pass in. It won't know how much the meal cost. It won't know how much the tip is, but it will define that function. So the final thing we want to do is run that function. And that's what this last line does. Now this last line looks a little confusing, and that's because I've been tricky and combined two different things onto a single line. So remember this print %.2f that we saw before is going to substitute in a float to 2 decimal places. So that makes sense. We need to substitute in some value to 2 decimal places. Then after the percentage sign, we're going to put what we need to substitute in. And previously that just said total. Previously we just substituted in the total value and printed it. But now what we want to print is whatever is returned by our function. So remember that total is returned from our function. So we're going to call the function within the print statement, give it the two arguments, and whatever is returned is going to be substituted into the print statement. Now I know that looks a little strange, and if that seems a little difficult to you, what you could do is break it up into two lines. You could have total equals calculate tip, and then on the next line substitute that total value in. But you'll find lots of people, and when you get code from other people in your lab, they'll be doing things like this. So we are calling the function, and whatever is returned is going to be substituted in here and printed to 2 decimal places by the print statement. So sys.argv1 is still going to be the first useful argument. Sys.argv2 is going to be the second. It will then call calculate tip with those two inputs. The first one will be set to the variable meal. The second one will be set to the variable tip. It'll convert them to floats, calculate the total, then it'll return this total variable. So all of this from calculate tip up to this last bracket will be replaced with whatever is returned from our calculate tip function. Thank you. Okay, so so this calculate tip, open brackets, all the way to the closed brackets, will be replaced by whatever is returned from running it. So this total variable will be substituted in here, and then the last line is just going to print that to 2 decimal places. So save that, and you should run it exactly the same way we ran it before. Maybe I'll have that on the next screen. So when you save it and run it, you should be able to run it exactly the same way. The only difference is now that our code contains a very nice, well-defined function that if we want to, we can pull out and use in different programs and et cetera, et cetera. Hey.
So why?
The issue is that the sys.argv doesn't have any variables in it. So if you wanted to make this a function that you could bring into Python as a module, you would first delete this print statement. You don't need the import sys. You just need everything from this def to the end of the indent. If you save that file without that, you should be able to do import tip calculator, or from tip calculator import calculate tip. No worries. Okay, so we saw them briefly, but let me introduce them more thoroughly. For loops are one of the most useful ways of executing code in Python. They allow us to do something repeatedly for an entire data structure. So often you're working with a large data file. Perhaps it's all the time points in your experiment and you want to normalize them. Perhaps it's every gene in a gene list and you want to look up some value for that gene. That's where for loops come in. Whenever you want to do something repeatedly for every element in a data structure, that is a good use of for loops. So the way they work is like this. The code goes through line by line. We reach the for loop, and the syntax will look like this: for variable name in list name, colon new line indentation. And what it will do is it will get the first element out of the list the first time, store that as the variable, and then we can do something on that variable. It will reach the end of the indented code. It will set variable equal to the next item in the list, and then we can do the same stuff again. So it's each time going to go through getting out an element one at a time and allow us to do the same thing on that element. So let's have a look at an example. I'm going to define a list. I'm now launching back into the interactive environment. I've typed Python. You can see the chevrons at the start of my line, those arrows, which mean I'm in the interactive environment because we're just figuring out for loops for now. And I'm going to define a variable called myList and set it equal to these three numbers, a couple of integers and a float. Then what I can do is for num in myList, colon new line indentation, print 2 to the power of num. And what that will do is it will set num equal to the first value in the list the first time, and then print 2 to the power of that value. It will then set num equal to the second value in the list the second time and print 2 to the power of that value, etc., all the way through the list until the list runs out. And you should see all of those numbers in the list squared printed to the screen. So one thing I want to remind you of is not to be lazy like me. And if you want to write code that can run in Python 3, even if you're not running Python 3 right now, rather than print 2 to the power of num, it's a good habit to put these brackets around it to make sure it works in Python version 3. Okay, so just to remind you, the num will be set equal to 4 the first time, and then it will print 2 to the power of 4. Num will be set equal to 1 the next time, it'll print 2 to the power of 1. Num will be set to 3.14 the next time, and it will print 2 to the power of that. And then we should see all those numbers printed to the screen. Anyone not see those numbers? So what we can also do is do for loops over dictionaries. You don't have to just do them over lists. Remember, however, that dictionaries don't have an order. They're not for storing ordered data. So this is only useful if we want to do the same thing to every element in a dictionary and we don't care what order it happens in. And that's often the case, if you want to normalize your values to some mean. We don't have to go through our values in order. But let's have a look at how we will go through a dictionary. It's very similar, except rather than setting the value, so previously we saw num set to the first value in our list, num set to the second value in our list. When we do it with a dictionary, what it will do is it will set the variable here to each key in the dictionary in turn. Remember that dictionaries have key and value pairs, and the way for loops work on dictionaries is that it will set the key each time to that variable. Okay, so my dictionary equals, exp1 has the value 100, exp2 has the value 500, exp3 has the value 350. Remember, dictionaries have those curly braces on the outside. They're separated by commas, and they have key and value pairs separated by colons. And then we write a for loop that looks very similar. For key in my dictionary, colon, new line, indentation. What that is going to do is set key equal to exp1, key equal to exp2, key equal to exp3 as it goes through the dictionary. Note perhaps not in that order, just because dictionaries don't have a defined order. So what can we do for each of those keys? Well, let's print something. Let's print that the key is some string and the value is some number. Now, if you remember previously, I've done %s to substitute a string into a print statement. I've done %f to substitute a number with some decimal place information. Here I'm going to use %i, which is just another way of saying that I have a number. This time it's going to be a whole number, so I'm using %i. There's a bunch of these different things, which I won't go into all of them. You can look them up online. We're mainly going to be using %s, %f, and %i. But all this means is that I want to type key is some string and value is some number. And then what do I want to substitute into those positions? Well, the first thing I want to substitute in is the key variable, which will be exp1 or exp2 or exp3. And in the number position, what I want to substitute in is the value associated with that key. Remember, to get the value associated with the key in a dictionary, you type the dictionary name, and then in square brackets you put the key. So here, let's say key is exp3. It's going to print key, colon, exp3, value, colon, whatever value is associated with the key exp3, which it will look up and find 350. So it'll print key exp3, value 350. And that's what we see printed here. So it's going to do that for every key in the dictionary. It's going to print its key, it's going to print its associated value on the screen like that. Note we have this extra blank line where we've hit enter one more time to tell Python that we're done writing indented code, that this is the end of the for loop and there's nothing else. So it doesn't need to keep waiting, it can execute the full loop now. So we can also do for loops on strings, lists, dictionaries, many different data types. Remember that strings are a lot like lists, so this will do something similar to what you might expect if it was a list of letters. So I'm going to define my string equal to Python. This is useful. You might be working with a set of nucleotides and you might be looking up complement nucleotides or looking for an adapter sequence or something. You might be going through a string when you're doing that processing. So if my string is the text Python, then I'm going to define a new string to have no letters in it yet, but I'm doing that so I can fill it with values as I go along. So I've got two variables defined. One is the string Python, and one is an empty string. And then what I'm going to do is for every letter in my string, do something. You'll note the for loop has looked slightly different in each of my examples. Here I've done for letter in my string. Here I did for key in my dictionary, and here I did for num in my list. It doesn't matter what you put in that second position, it's just for some variable in some data structure. So the name I've given them has been descriptive, but it's not important that it is exactly what I say. So here you don't have to say for letter in my string. You could say for my variable in my string, or for a letter variable, whatever you want to call this. You could call it John if you wanted to. Whatever you call your variable here is fine as long as you're consistent when you refer to it down here. But it's good to give it a descriptive name. So we know this is going to go through letter by letter, so I've called it letter. So for letter in my string, colon new line indentation, and what that is going to do is set letter equal to P the first time, letter equal to Y the second time, letter equal to T the third time, etc. So what do I want to do for each of those letters? Well, I want to do my new string plus equals 2 times letter. So there's a couple of new things here. The plus equals, whenever you see a plus equals, that's exactly the same as saying the old value plus a new value. So if I do my var plus equals 1, that's exactly the same as saying my var equals whatever value it currently has plus 1. So here we're doing my new string plus equals something. That means I'm going to do my new string has whatever its current value is plus some new values. We know when we do plus on a string that it concatenates onto the end. So what this is going to do is add some more letters onto the end of my string. So in this example, what that line looks like is my new string equals my new string plus 2 times letter. Okay, so what that means is that it's going to start with my new string being empty because we defined it here. Then it's going to do my new string equals whatever it currently is, which is empty, with 2 times the letter P concatenated on the end. Then it's going to get the letter Y. It's going to do my new string equals whatever it currently equals plus 2 times the letter Y. And so we get 2 Ys added onto the end of the 2 Ps. Then we do my new string equals 2 times the letter whatever. And so it goes through adding 2 times the letters of Python into my new string. And when we run that loop and have a look at the value of my new string, you should see that it contains Python with every letter doubled. So the first time, letter will be P. It'll do my new string equals its current value plus 2 of the letter Ps. Then letter will be Y. It'll do my new string equals its current value plus 2 times the letter Y. So we get P, P, Y, Y, and it will go through all the way. Does that make sense? Awesome, great. Okay, so another useful function when we're working with lists that I want to introduce is the range function. Often when we're doing these loops, we're doing something over a predefined range. We might have a list of time points or a list of replicates, and for the purposes of looping, we might want all the numbers between 1 and 10, because those are our 10 time points. So what we have is the range function here, and that simply defines a list of numbers for us. So let's say we want all the numbers between 0 and 9. All we need to do is type range brackets 10. And that will go from 0 up to 10, up to but not including 10. Remember, we always have this up to but not including thing going on with our second index. So range 10 is exactly the same as typing range brackets 0 to 10. We go from index 0 up to but not including 10, and you should get back a list of all the numbers between 0 and up to but not including 10. So this is a useful way of defining a list of sequential numbers that you might use, I don't know, to label the time points of your data or to loop through and do something repeatedly. It saves you typing 0, 1, 2. So range can also do lists in reverse order. If you want to go from 0 to minus 10, you then have to tell it a third argument, which is this step size, which will tell Python that we want to go from 0 to minus 10 with a step size of minus 1. And that will tell Python to go backwards from 0 to minus 10. And so when you run that, you get all the numbers between 0 and minus 10. Be aware of a few of the tricky things that you might see. If you just do range 0, you're going to get an empty list back because it goes from 0 to 0 but doesn't include 0. It's a little strange. If you go from 1 to 0 with a step size of minus 1, it's going to include 1, not include 0, and so you'll only get 1 back. So that makes sense. Okay, so let's see what we might be able to do with that. I'm going to define a variable called myRange. I'm going to set it equal to the range 0 to 10 with a step size of 3. So that's going to be 0, and then 3, and then 6, and then 9. And then it will try and get 12, but fail because 12 is beyond 10. So my range is all the numbers between 0 and 10 with a step size of 3. And then what I do is, for num in my range, let's print that number. Remember, if you're going to be a good student, to put the brackets around the number to make it Python work with different versions of Python. So for num in my range, we'll set num equal to the first element of my range the first time and then print it, num equal to the second value of my range the second time and then print it, all the way through, and then you should see all the numbers between 0 and 10 printed with a step size of 3, so 0, 3, 6, and 9.